Good morning and Jai Hind to all. Hopefully, the unit that we have done earlier is all the concept in that unit are clear to you. So today we will start our next unit, that is unit number 8, that is atomic nucleus. So in this, before starting this unit, we will discuss some basic concepts that are made to study the structure of a nucleus and atom basically. So we will start with the first Rutherford's alpha scattering experiment. So I will explain first the experimental setup of this experiment. There is a lead box. The property of lead is that it absorbs all the radiation. It is a material that can absorb most of the radiation that fall upon it. That's why we use a lead box, and here is on small slit through which only a single beam of alpha particles can escape. Here in between this lead box there is a radon sample which can emit alpha particles. So when alpha beam, there is a thin gold foil and there is a ZNS screen. It is a fluorescent screen. Whenever any radiations strike over this screen, there will be spots on the screen, and there will be pattern that can be visualized later. That's why we use ZNS screen. So alpha beam is emitted by this radon, and it is made to fall over thin gold foil. So this gold, from after striking over this thin gold foil, the beam of alpha particles will be scattered in a various direction. Like some of the alpha particles will go in this direction, some will in this direction, and some will in this, and some will even come back following the same path. Some will be scattered in the other direction. So this was the Rutherford's alpha scattering experiment. So here we analyzed this ZNS screen and found that most of the alpha particles suffer huge reflections. Alpha particles carry positive charge. This means that there might be some positive charge who is repelling the positive alpha particle charge, alpha particle. So that's why most of the alpha particles come back suffering huge deflections. Most of the alpha particles go with undeflected or suffer very small deflection. This means there is no obstacle in their path, means the positive charge is concentrated in a very small region. That's why Rutherford also made a graph between scattering angle and number of alpha particles scattered. So a line was obtained like this. This means most of the particles suffer very small scattering angle. Very small angle of scattering is there for most of the particles. So based on these assumptions, he concluded these observation that most of the alpha particles passed straight through the gold foil. It indicates that most of the space in an atom is empty. Second is some of the alpha particles were scattered by only small angles of order of a few degrees. So alpha particles being positively charged and heavy compared to electron could only be deflected by heavy positive region in an atom. It indicates that positive charges and most of the mass of atom are concentrated at a center, that is called nucleus. That this is how we got to know about the nucleus. A few alpha particles were deflected through large angles. Some of them even retraced their paths. The deflection was 180 degree, means they went there and after striking they retraced their paths by 180 degree. So alpha particles which travel towards the nucleus directly get retarded due to Coulomb's force of repulsion. As we know, positive charge repel positive charge, so there is a huge deflection retarded due to Coulomb's force of repulsion, and ultimately comes to rest and then fly off in opposite direction. So this was found there. N is the number of alpha particles scattered that are directly proportional to sine raised to power 4. Angle mean this theta is the angle of scattering. So this was the general observation that was made by the Rutherford. So Rutherford, based on this experiment, was able to explain the structure of a nucleus. So he found that in an atom most of the space is empty, and positive charge and mass of the atom is generally concentrated in a very small region that is present at the center, and he named that center as nucleus of the atom. This was the main discovery that he made based on these observations. Now there are some important terms introduced here also. Distance of closest approach. When the distance between alpha particle and the nucleus is equal to distance of closest approach, alpha particles comes to rest. So suppose here is a radon and beam of alpha particle is going towards the nucleus. So after traveling some distance, it will be reflected back, it will be repelled back in the same direction. So there might be some distance, smallest distance, that is called distance of closest approach, up to which an alpha particle can approach towards the nucleus. It is the smallest distance between nucleus and alpha particle up to which alpha particle can traverse the atom. So at this point of distance, kinetic energy of alpha particle is completely converted into electrical potential energy of the system. So what is kinetic energy? That means half mu square equals to, this is the formula of electrical potential energy, that must be equal, that means 1 by 4 pi epsilon naught equals to 2 ZE square upon R naught. R naught, what is the R naught? R naught is distance between these two particles, like this positive nucleus and this alpha particle. So rearranging this, we are able to calculate distance of closest, expression for distance of closest approach. Now what is impact parameter? The perpendicular distance of velocity vector of alpha particle from the center of nucleus when it is far away from the nucleus is known as impact parameter. So this is the term when alpha particles are deflected by very small scattering angles. So in that case there is a line that passes through the center of the nucleus. So the perpendicular distance between both of them, the velocity vector and this central line, is called impact parameter, and this is the expression for impact parameter. It is denoted by B. So it was found that for large values of b, cot theta by 2 is large and scattering angle is small. This means alpha particle traveling far away from nucleus suffer small deflections. So the alpha particle that are very far from the nucleus, they will suffer very small deflections. Similarly, for the second, for small values of b, cot theta by 2 is small and theta, the scattering angle is large. So alpha particle is traveling to the, whenever alpha particle is traveling close to the nucleus, it will suffer large deflections. Means this is the case when alpha particle retraced its path by 180 degree, or it will come back in the same direction. For third, for b equals to 0 means impact parameter is 0, alpha particle directed towards the center of nucleus, it is following this line, this central line. For this, cot theta by 2 is 0, means theta by 2 is equals to 90 and theta is equal to 180 degree, means in that case the deflection will be 180 degrees. So with this we explained all the factors that are related with his experiment, his observation, and the conclusions he made on this basis, and the discoveries that led him to some fruitful conclusion. So hopefully all of you have understood the topic of this video. I will ask you question related to this in the assignment. If you have any queries, you can ask me personally, and you can comment in the comment section also. Thank you so much.